All right, good morning. Here we go. Today we are talking about isosceles and equilateral triangles. And so we're basically, setting more problems up, doing more solving. Pretty easy again today, which is kind of nice. At the very first day, we learned about isosceles triangles. And of course, an isosceles triangle, what do you know about isosceles triangles? Two congruent sides. Very good. Two congruent sides. Very important. And so as long as you know that, that's pretty good. It turns out that those two congruent sides are called the legs. The legs of the isosceles triangle. And so here on this particular example, here are your two legs. We have those two congruent sides. Those are called the legs. The angle where the legs intersect is called the vertex angle. And so right here, the two congruent legs are intersecting at point B. So this is what we would call the vertex angle or vertex. The side opposite the vertex angle is called the base. And so if we're here at the vertex angle, where is the opposite side? Crickets. Bless you. If B is the vertex angle, where is the opposite side? AC, yeah. So here's our vertex, and if you go across the triangle and hit a side, this is the opposite side, and this is then called the base. And so that's important. And then the angles along the base are called base angles. And so here, angle A and angle C, these are the base angles. Base angle, and right there is another base angle. Now, I marked those pretty special there. You'll notice that I marked them congruent because that happens to be our isosceles triangle theorem. That says if two sides of a triangle are congruent. So you can see in this picture we have two sides, our two legs are congruent. Then the angles opposite those sides are also congruent. So if this is my side AB is congruent, then that angle opposite and the other angle opposite the other congruent leg, they happen to be congruent. Well, I like to sum that up in if two congruent sides, then the base angles are congruent. This is the same way I did it when I was in geometry. My teacher. This was how we said this theorem. If the two legs are congruent, then the opposite angles are also congruent. The converse of the isosceles theorem is that if two angles of a triangle are congruent, then the sides opposite are also congruent. So if I have two angles are congruent, then the two sides are congruent. The opposite sides are also congruent. And so that's basically how we sum that up there.
Angry triangle.
Does it look like an angry triangle? All right.
It looks like that one angry bird, the yellow one.
Oh yeah, the triangle one.
Funny. Yeah, so if the base angles are congruent, then the opposite sides are also congruent. And we're going to use those today to kind of justify our equations that we're going to set up, all right? So we want to use this new information about isosceles triangle. And what you want to understand is that this triangle looks like it's resting on its base, okay? But the fact that it's this orientation makes no difference. If it was upside down, we have our two congruent legs. This is still the vertex angle, and this is still the base, even though it's on top, okay? So it doesn't mean that the base is at the bottom. It's based on what's congruent. So for instance, let's look at these couple here. So number one, we want to find each measure here. And we have two congruent legs. So these are both the legs, two legs of our triangle. And so what's the base?
Would the measure of J be 68?
It would be, absolutely. But my question was, what is the base? JL. JL is the base. And so, yeah, if our two legs are congruent, then the opposite angles are also congruent. So both of these angles would be 68. So J is 68 degrees, L is 68 degrees. How do we figure out the measure of angle K? Add 68 and 68 and then minus from 180. Right, so 44. Yeah, so again, the sum of the interior angles in a triangle is 180. So if we do 180 minus 68 minus 68, that's going to get us that third angle K at 44. Okay, so here we have number two, a slightly changed orientation of a triangle here. And I have my two legs. The legs are the things that are marked congruent. So I have two congruent legs. So my question, what's the base? CE, yeah, CE is called the base, even though it's sort of hovering up in the air. All right, and so if those two, if that's the base, what else do we know? If we have two congruent legs, what do we have? Two congruent angles. Which two angles are congruent? So this is the key. We do know that this is the base. The base angles are also congruent. So here we have angle C and angle E. Those are the angles across from their congruent sides. So, and then divided by 2. Very good. Yeah. So to figure out the measure of these two angles, we know that we have this large obtuse angle. So 180 minus 106 gives me 74. Okay, so we have 74 degrees to split between two congruent angles. So what do we need to do with that 74? Divide it by 2. 74 divided by 2 is? 37. So each of those is 37 degrees. Perfect. All right, the converse here on number 3. What information are they telling us on number 3? The base angles are congruent, and if our base angles are congruent, what else is congruent? The legs are congruent. So what are the legs? Okay, so XY is one of them. What's the other one? ZY, okay. So those legs are congruent. That must also be 12 centimeters. So YZ is also 12 centimeters. And how do we figure out angle Y?
Would angle Y be 26?
It is. Why? How'd you get 20?
180 minus 77 minus 70.
Yeah, good. So we have 180 degrees minus the two angles we know, and we do get 26. All right, fantastic. So let's look at number 5. Number 5, we have two congruent legs. Yeah, it does mean that. So if we have two congruent legs, what do we know? The two base angles are congruent, yes. So we have two congruent base angles. And that means that 4x plus 7 is going to be equal to 9x minus 33. How do you want to solve that? Minus the 4x, all right, so that gives me 5x minus 33 equals the 7. And then? Add the 33. 7 plus 33 is going to give me 40, which means x equals 8. All right.
And then you would plug them back into.
Maybe, except it just said to find the value of the variable. So our variable is x, its value is 8. All right, great. Number 7, what are they telling us in number 7 very discreetly?
So we have two, that our base angles are.
That the base angles are congruent, all right. If our base angles are congruent, then what can we conclude?
That our legs are congruent.
Then the two legs are congruent. Very good. So we must know that our two legs are congruent there. And so what equation can we write?
3x plus 23 equals 9x minus 73.
Good. 3x plus 23 equals 9x minus 73. Do we need to solve that?
No.
All right, we get x equals 16 on that one. So pretty easy. We have our isosceles theorem and then the converse. So if the sides are congruent, then we know the base angles are, and if the base angles are, then we know that the legs are congruent. So pretty easy there. Any questions so far? All right, let's turn to page. Yeah. Paper.
Paper all week.
Paper, yep. Paper all week. It was true.
Listening here. If you were on time. Yeah, how, if I wasn't on time yesterday, how would I know that?
All right, here we go, gentlemen. Let's look at number 9. In triangle DEF, did they give us a picture?
No.
No, what should we do?
Draw it.
Draw our own. So go ahead and draw any size, shape, triangle you want and label each vertex DEF. It does not matter how you draw it as long as you follow instructions. All right. Now, in my information here, it says angle D is congruent to angle E. So I'm going to mark my picture. Angle D is congruent to angle E. You should mark your picture as well.
So we write base or DE
You can absolutely write the base if you need to. And let's see, but I'm going to fill in the rest of my information here. DE is going to be x plus 4. So I'm actually going to label that x plus 4. DE is my side. Don't confuse yourself, ladies and gentlemen. DE is a side length of the triangle as opposed to an angle. It doesn't have an angle symbol, so don't write it as an angle. Don't write it inside the little angle. DE is x plus 4. And let's see, we have EF. EF is right here. It's 4x minus 8. So 4x minus 8 is the length of EF, segment EF. And DF is 7x minus 35. 7x minus 35. Find x and the measure of each side. Now, this is a great question because they gave us distractor information. That's what it's called in the testing world. They gave us more information than we actually need. So, Cash, what are you thinking?
Since DE is congruent, we know that 4x minus 8.
DE is congruent to what?
Like each other.
Oh, so the angle D and angle E are congruent. So if we have two angles that are congruent, then what should we be able to conclude? So we've got some congruent legs. Ladies and gentlemen, we have a base here that was marked because we have the two angles, so that's the base. What are the two legs that are congruent? Okay, so EF and DF are congruent. Really important that we figure out the things that are congruent. And so this x plus 4, are we going to use this x plus 4 right now?
No.
Not right now. It's not going to help us set up our equation right now. So we do need to say that since our legs here are congruent, then we have 4x minus 8 is equal to 7x minus 35. I'm going to go ahead and subtract the 4x, so that gives me 3x minus 35 equals that negative 8. I'm going to add 35, and that gives me 27. And then divide by 3, I get x equals 9. All right, so now if x equals 9, then we need to figure out the measure of each side. So how are we going to figure out DE? Plug it in, plug it in. Yeah, 9 plus 4 is 13. That's a 3. All right, and then let's see. EF, 4 times 9 is 36, minus 8
28.
is 28. And then, they're both 28. Very good. And that's nice because they are congruent, so they absolutely should be the same. That's good. All right, questions for me on that? So easy, right? Great. So then we can extend that same idea to equilateral triangles. What does equilateral mean?
All three are
3 congruent sides. Well, it turns out that an equilateral triangle is really just a special case of an isosceles triangle. All right? So you imagine if we have 2 congruent sides, we already know that the base angles are also congruent. But in an equilateral triangle, hey, look, if I rotate the triangle, I still have another pair of congruent sides, which means that, hey, that other angle must also be congruent. So it's really just a special case of an isosceles triangle. So in a triangle is equilateral if and only if it is equiangular. What does equiangular mean? Yeah, 3 congruent angles. So if the measure of angle A is equal to the measure of angle B is equal to the measure of angle C, then if the angles are congruent, then the sides are also congruent. AB is equal to BC, and that's equal to AC. All 3 sides are equal. And the reverse is also true. If the sides are equal, then the angles are all equal. The measure of angle A is equal to the measure of angle B is equal to the measure of angle C. But really, I kind of just like if we know that all 3 angles are congruent, we get an if and only if. And if and only if we get to use the double arrow rather, then we know that we must have 3 congruent sides. And vice versa, it goes forwards and backwards. If we have 3 congruent angles, we've got 3 congruent sides. If we have 3 congruent sides, we've got 3 congruent angles. All right, so find each missing measure. Number 11, what's the measure of angle C? 60. How did you figure that out?
My brain. Because I did 60 plus 60, which is 180 minus 1.
Good. Yeah, so 180 minus each of those, minus 60 minus 60, is going to get us another 60. So every single equiangular triangle is a 60, 60, 60. That's the only option. Okay?
So then would both BC and AC just be the 9 feet?
Yeah, exactly. All 3 angles are congruent, which means all 3 sides are congruent as well. So all the sides are also 9 feet. It's a big, big triangle. The measure of angle C is 60 degrees. All right, number 12. All 3 sides are 24 centimeters. If all 3 sides are 24 centimeters, what also must be true?
All angles are.
All the angles have to be congruent. And what is 180 divided by 3? Yeah, 60 degrees. Every single time, since they're all the same. All right, 60, 60, 60. All right, number 13, triangle PQR is an equilateral. What does equilateral mean? 3 congruent sides. All right, 3 congruent sides. Solve for x and y. So we know that because it's equilateral, we have 3 congruent sides. What's an equation that I can write?
That.
So you just set all 3 equal to each other? Do we need to set, like...
Let's do...
Yeah, can we just pick 2?
Yeah, let's do 11y and 9y.
All right, why did you choose 11y minus 23 and 9y plus 1?
Because they're smaller.
Because they're smaller numbers, yeah. 11y minus 23 is equal to 9y plus 1. That's all we need. They must be the same. That'll help us figure out why. Let's see, I'm going to subtract 9, so that gives me 2y minus 23 equals 1. I'm going to add the 23, so I get 2y equals 24, so y equals 12. All right, now if we have 3 congruent sides, what also must be true? 3 congruent angles, yeah? So what is the measure of each angle then?
7x minus 50.
60. Every single angle is got to be 60. So what other equation can we write?
7x minus 3 equals 60.
7x minus 3 equals 60. Very good. Because in order to have 3 congruent angles in a triangle, they must all be the same 60 degrees. So 7x minus 3 equals 60. We can add 3 and get 63 and divide by 7 and get 9. All right. Do you guys have questions for me? No? All right. Super duper. Fantastic. Look at that. 21 minutes there.